Hello, dear students. Today I am going to discuss question number 13 and question number 14 of the chapter on fluid mechanics in the book Gupta and Gupta. So, let us start with question number 13. Question number 13 says the pressure of 200 kilopascals is equivalent to head of X meters of carbon tetrachloride whose relative density is 1.59, where X is equal to, so we need to find the value of X. Let me repeat the question once again. We have been given a pressure of 200 kilopascals and we have to find the equivalent of this 200 kilopascal in terms of the head of carbon tetrachloride. So let us imagine that there is a liquid in a container, and if we want to know the pressure at any depth in this liquid container, say at this point, and let us assume that this point is located at a depth of h from the free surface, then the pressure at this point is rho g h, where rho is the density of this liquid, g is the acceleration due to gravity, and h is the depth of this point in this liquid container from the free surface. Suppose if we want to know the depth here, then this pressure at this depth, say this depth is h1, pressure at this point, say this is point 1, is rho g h1. We can assume any random point in this container, and the pressure at that point is rho times g times the depth of this point from the free surface. And there is one more thing that we need to note. If the pressure at this point is rho gh, then the pressure at all the points in this level is exactly the same. Similarly, if at point 1 the pressure is rho times g times h1, then the pressure at all points in the level of this point 1 is the same. And even if you distort the shape of this container, say the container is like this, the container is like this, the pressure at a given level is going to be same irrespective of the shape of the container, given that the liquid in the container is same throughout. All right, so now we have a formula rho g and h which connects the pressure at a point with the depth of that point from the free surface. You can also call this depth as head. So we have a formula which relates pressure at the point with the head at a point. So in this question, we have been given that the pressure is 200 kilopascals. And let us imagine that the situation is that we have a container which consists of carbon tetrachloride liquid, and we have been already told that the pressure at some point in this container which has carbon tetrachloride is 200 kilopascals. So we know that this 200 kilopascal pressure would be equal to rho times G times the depth of this point in the carbon tetrachloride in this container. So using this formula, that is rho GH, we can find the head using this formula we can find the pressure in terms of the head of carbon tetrachloride. In this context, this H has been denoted as X. That means the pressure of 200 kilopascals is equal to rho Gx. All right, so we can solve this simple equation to find the value of X, and that would be 200 times 10 to the power 3 times Pascal upon rho G. Rho times G is 9.81 meter per second square. Now in this scenario we have been given relative density of carbon tetrachloride as 1.59 instead of the density, and we know that relative density is equal to density of any liquid, which is carbon tetrachloride in this context, upon the density of water. So the density of carbon tetrachloride, which is the liquid in question, equals 1.59 times the density of water, which is 1000 kilograms per meter cube. That means the density of carbon tetrachloride is 1590 kilograms per meter cube. So let us plug in this value in this equation for determining the head. So head would be equal to 200 times 10 to the power 3 pascals upon 1590, which is the density of carbon tetrachloride, times 9.81 meter per second square. So if we solve this equation, the value of X becomes 12.82 meters, because here Pascal is Newton per meter square, so all the parameters are in similar units, that is in meters. So the resulting value of head x is equal to 12.82 meters. So the answer of this question is option C, that is 12.82.